Hey guys, this is Mr. Lee. So this is our last lecture on chapter 15. So where did we end up? We ended up figuring out with Minitab output. We really appreciate Minitab output because here's your coefficient of the constant, which is your y-intercept negative 0.03761. Here is your b, your sample slope, the coefficient of whatever variable it is in context, your x variable. So that slope is 0.005724. Now this slope is very close to zero. Okay, so note that. If you need to do any calculations by hand, which you probably will not, unless there's some kind of specific question on that, here's your standard error of B if you wanted to use that for doing some calculations by hand. And then this number is important also, this S. This is the standard deviation of the residuals. And recall that we use S to estimate sigma, since we're not going to know what the true standard deviation is in the population of all of the y variables. So this we do definitely use. So here's our least squares regression line for these data. So this is our sample regression line. Predicted flight time is equal to, there's your y-intercept, your A, plus there's your B, your sample slope, and then there's your x variable. Okay, so let's get to the sampling distribution. Let's talk a little bit about the sampling distribution, then we'll get to the step-by-step on constructing a confidence interval and performing a hypothesis test. So the sampling distribution of B is going to look something like this. It's going to be normal. Okay, it's going to be centered at the true beta, the true population slope. And what do you need to know? Well, we're not going to know sigma, okay, because sigma is the true population standard deviation. For this first example, we gave you sigma, but you're never going to really know what sigma is. And so instead of this, we're going to use standard error, not sigma, not the standard deviation of the sample slope, but we're going to use standard error. So that equation at the bottom, that formula at the bottom is what you're going to need to know. Standard error of slope is S, and remember S is the standard deviation of the residuals over sample standard deviation times root n minus 1. Okay, so because we're not dealing with sigma, okay, we're going to be dealing with t, okay, because we don't know what sigma is. So t is equal to, okay, your statistic minus your parameter over your standard deviation of the statistic. But of course, we don't have the standard deviation of the statistic, so we're using the standard error of the statistic, and that's why we're using the student's t instead of the standard normal distribution. Okay. Remember that when we're using the student's t for inference for slope, we are using n minus 2 degrees of freedom, which is more accurate than anything else. So let's go ahead and go to a confidence interval. Recall that a confidence interval in general is just your statistic, which is your point estimate, plus or minus. This entire thing is called the margin of error. And what we do is we break up that margin of error into two parts. One is the critical value, in this case, your t star, okay, times the standard deviation of the statistic, which we don't know. So we're using the standard error of the statistic. Okay, so there is your formula for standard error. Again, make sure that you know that. Also recall that we have n minus 2. To find your t star, you're just going to use inverse t. Okay, just like we have all year long, we've used inverse t, and we also used inverse norm. Inverse t works the same way. Just be careful that your df is n minus 2. Again, it's really nice when you have Minitab output because your standard error is right there. So all you have to do is figure out what your t star is going to be, right? So go ahead and see if you can figure out what the t star is for a 95% confidence interval with 68 degrees of freedom. Okay. All right, so what did you do? You just went to second distribution. You went down to inverse t. For area, for 95%, because it's including the left tail, you put in 0.975. For DF, you put in 68, which is n minus 2. Then you went ahead and pasted it and pressed enter, and you get 1.995468907, or approximately 2. Okay, if you use the table, you would get 2. So there's your interval, and the interpretation of the interval is the same. We are 95% confident that the interval from lower bound to upper bound seconds per centimeter captures the true slope, or the slope of the true regression line relating the flight time y and the drop height x of paper helicopters. So that is your conclusion for your confidence interval. So now let's go to, let's do one more example with NEA, non-exercise activity versus fat gain. We have the Minitab output right here. So can you go ahead and real quick put together a confidence interval for this? Remember that we have 16, n is equal to 16 in this case. Okay, so here's your state and your plan. Remember that your conditions for your plan, you have to show the residual plot. Okay, you might want to show, if they have the actual plot of the data, that's nice to show as well. But you definitely want to examine your residual plot and probably your normal probability plot as well. They used a histogram of the residuals, which you have to be able to use that if that's what's provided to you. But if you're looking at a histogram of your residuals, what you're looking at is approximately normal, unimodal, and roughly symmetric. Okay. But again, if you have the actual data and you're doing the regression on your calculator, I suggest that you use a normal probability plot of your residuals. So if you're due, make sure that you show this generalized form of the formula, substitute in the values, then give the final answer. Okay, and just do this on your calculator. Your conclusion, we are 90% confident that the interval from this lower bound to this upper bound in kilograms captures the actual slope of the population regression line relating NEA change to fat gain for healthy young adults. Okay. What are we trying to capture? We're trying to capture beta. Okay. So now we get to a hypothesis test. So for the hypothesis test, the null hypothesis is always going to be, okay, beta equals what? The null hypothesis is going to be that there is no linear relationship in the population. So beta equals 0 is always going to be our state. Okay. Your alternative is going to be beta is positively sloped or beta is negatively sloped. Okay. So remember to have both null and alternative hypotheses. Because you're stating a parameter beta, define what your parameter is in context, and also state your alpha level. So you have to have 4 things in your state. Plan, again, is the 5 liner LINER conditions. Here's what I like to see. I like to see the normal probability plot of the residuals against the Y's. You can do it against the Z's also. They did residuals against the Z's. But if you do it against the Y's, you're going to see a very linear pattern as well. Equal variance, you want a roughly equal variation, okay, about the 0 line. For the due, this is really, really nice because check this out. They give you the T right here, 3.07, okay? So they literally give you everything you need. Not only do they give you the T test statistic, but they also give you the p-value that's associated with this T test statistic. So everything is done for you. You just have to know where to look. It's right here and it's right here. One thing to keep in mind, and write this in your notes, this p-value is for a one-sided test. excuse me, it's for a two-sided test. So for the one-sided test, you have to take half of this p-value. Okay, this p-value, and that's true with all Minitab output, no matter what procedure we're doing. When Minitab gives you a p, it's always giving it to you as a two-tailed outcome. So you have to do, if you're doing a one-sided test, which we were, our beta was greater than 0 was our alternative hypothesis, excuse me. You have to take half of this p-value. There's our conclusion. The p-value of 0.002 is less than our alpha equals 0.05 significance level. So we have enough evidence to reject H null. Okay, next sentence. This provides evidence that there is a positive linear relationship between intensity of crying and IQ score in the population of infants. Guys, that's all we have. Hope you enjoyed this chapter. Hope you enjoyed all of these videos and all of these lectures that we've had together. And hope you enjoyed hearing my dogs coughing in the background or barking or whatever. It's been a great year. And now it's time to wrap things up for our textbook and do some cumulative review, get you guys ready to all get 5s on the AP exam. Thanks, guys.